Hi there. Okay, here we go. Next lecture. Today we're going to be talking a little bit more about measurement, and this is basically part 2 of the measurement lecture. So it's still 2.2 units of measurement, but we're continuing it here. Getting to the stuff we didn't get to last time. So we're not going to belabor all the objectives and stuff like that. Basically, we want to teach you how to convert from unit to unit. Excuse me. We want to teach you the way that we want you to show your work in the stuff that we do, and then basically practice some of those calculations, and then we'll go on from there. Okay, so let's get to it, and we're going to kind of go back a few screens here. Theoretically, we're going to go back a few screens. I have the best luck, don't I? There we go. Okay, so let's start with that required step format. Almost there. Boom, 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 boom. Okay. So let's say we have a question like this. What's the mass of a cube with a volume of 10 cubic centimeters and a density of 0.20 grams per cubic centimeter? Anytime that you are being given a problem that is solved with the use of a formula, what we're looking for is for you to show the step format. And we use the acronym GEMS, G-E-M-S-S, in order to signify what steps you should be following. So this one is going to be one that ends up having a formula, right? So we just learned the density formula. You can see volume, you can see density, and they're asking for mass. So they're asking for the M, they're giving you the D and the V. So let's look at how that would go. The first thing you need to do is write out your givens. That's the G of GEMS. The givens, write out all of your unknowns and your knowns. So V equals 10 cubic centimeters, D equals 0.20 grams per cubic centimeter, M equals question mark number of grams, okay? And then you go to E. That's your givens, that's your unknowns. Don't forget the unknown question mark with a unit. Don't forget that unit there. Then the E, write original equation. So what equation is it that you're using to solve this? Now, this sometimes can get a little confusing to people because of this word original. Some of you guys like to just kind of reformulate the equation in your head. Great, I'm glad that you can do that. But write down the standard formula that we have taught you. In this case, density equals mass divided by volume. We didn't teach you the rearranged form of that. So write down the original formula for the equation. The next step is where you're going to show me that you can do the algebra to manipulate. That's the M, right? So G-E-M of GEMS. Manipulate the equation. Now, sometimes you don't need this step. Like for a problem where we're solving for density, you can leave this. This step M is not necessary because you don't have to manipulate it to solve. But in this case, it is necessary because you've got mass that you're solving for. So you have to rearrange your equation in order to solve for mass. Now, real quick on that one, there's a couple key little tricks that you can remember that if you're ever solving for instance, the thing that's on the bottom here, like if I were solving for the volume, I can just swap these two pieces here, all right? That's a pretty easy way to redo that formula. However, if I'm solving for the thing that's on top on the other side, then I have to remember that this formula is basically just rearranging, okay? I'm going to say, well, if I want to get M on the other side, then I'm going to need to divide both sides by M, right? So I've got to divide this side by M and then this side by M. So I'm going to rewrite this so that we can see what's going on a little bit easier. All right, so let's say I say, hey, I want to get the M on the other side of the equation. Now, it's kind of silly because if you think about it, really, I can just do the V and I've got it taken care of, right? So let me just make that a little more simplistic on myself. Let me not try to get the M on the other side. Let me just put M by itself. See why that's better? We don't have to think of getting the M to the left side because it doesn't really matter if it's on the left or the right side. It needs to be by itself. So the V is down here. So if I want to get them by themselves, I have to multiply both sides by V. Remember, whatever you do to one side of the equation, you need to do to the other side of the equation. And so these V's cancel out with each other and basically make a 1, right? And now I have my M by itself, and now I have my new formula. So M is equal to D times V. You see what's happening there? So I know many of you guys know that, but it's nice for you guys to see that again because sometimes we forget. So that's how you manipulate these types of formulas. It's just algebraic manipulation. Then you're going to substitute. Now this step is important. This step is a step that shows that you know what you're doing. that you know what values go in what places. So my D needs to have density in it with units. Do not forget the units. You're going to lose points if you don't show units. And then my V, 10 cubic centimeters. Again, don't forget the units. So now that's my substitute value. And now I go to the next step, which is to solve. All right, so my final GEMS, G-E-M-S-S, I solve it. And I want to make sure I always box the answer. And I want to make sure that I express my answer in the correct number of significant figures. You haven't learned about that yet, but when we do it, make sure you do that. Box that answer and you're going to be finalized. Okay, that's the way we do our step format. Now, what we're supposed to do, let's see if we can actually practice one and do it on our own. Okay, so we've got this question here. What's the density of a block of a substance that occupies 12.8 cubic centimeters and has a mass of 34.00 grams? Go ahead and see if you can do it. Don't forget to show step format. Hit the pause. And we're back. Okay, so let's see if we're doing our GEMS, givens, right? So let's show our givens. And again, you could list these in a place where it's going to be, downwards. You don't have to list them across, but make sure that you show your units in this. You'll lose points if you don't. There's a question mark with the units that you know you're going to need. Then we go to our original equation. So you would have next done that formula, showed that formula. Here's a great spot for this one, 3 points. You don't have to manipulate because that's actually the same equation you need for what you're solving for. So you just get a free bonus point. Every time I grade these are just 5 points, 1 point for each step, and then you lose some points for, units and significant figures, things like that. So then you substitute 34.00 grams, 12.8 cubic centimeters. Make sure to show your units there. And you finally solve. And so you're going to plug that into your calculator and come up with your answer. And don't forget to do what? That's right. Don't forget to box your answer. And again, the reason we do boxing instead of circling, it does need to be a box instead of a circle, is because people sometimes tend to circle things on their paper as they're doodling and thinking, and they don't usually box. And so it just makes for a good distinction in what you want your answer to be. Okay, so let's then answer these questions. Would the substance sink or float in water? Explain. And if the block is cut in half, what happens to the density? So hit the pause button, pause it, and we're back. So, would the substance sink or float in water? Well, what was the density? 2.66 grams per cubic centimeter. You memorized that water's density was 1 gram per cubic centimeter. Density of this block is greater than water, so it sinks, all right? And that's your explanation. Density greater, more dense things going to sink to below the things that are less dense. And that's called buoyancy. If the block is cut in half, what happens to the density? Well, remember that density is an intensive property. It's not extensive, which means it does not get changed by the amount of matter in the substance. So the block is going to have, the block that's cut in half is going to have the exact same density as the block that wasn't cut in half. Now here's a couple more density practice problems. If you'd like to do those, pause it. Okay, but we'll probably do those in class. The answers to these, you can see, boom, boom, 1.14 grams and 5.60 milliliters. So let's see, maybe you got those right. If not, hey, you can talk to me about those in class as we get going, all right? All right, so let's look at our objectives here. Yeah, we did those before. This one right here, list and convert between SI prefixes. I want to work on that one a little bit more. We can definitely apply the step format for calculations and perform density calculations now. But let's go over listing and converting between SI prefixes, right? You have to be given 2 prefixes per unit that you can convert a quantity between them, okay? And so let's go ahead and practice that real quick because I don't think we've done that quite enough. So let's see what that problem would look like. Let's say we have, I want you to convert 15.7 kilometers into, millimeters, okay? So when we do these problems, it's important that you make these problems as unit conversion problems where you're putting one number over the other in a fraction sense. So always start with what you're given. Here's my given, 15.7 kilometers. Now what am I going to do? I'm going to use parentheses here instead of a multiplication sign because in physics, you can actually use that X there and it means something a little bit different. Chemistry doesn't usually matter, wouldn't bother you one way or the other. But in this case, we want to go ahead and use parentheses, and I want you to try to learn that method so that when you're taking physics, you get it right. Okay, so then we can go ahead and we always want to put what's on bottom, the thing that's going to cancel out with what's on top on the other side. And so we say, okay, kilometers are here. Now, do I know the direct conversion between kilometers and millimeters? No, I don't. I mean, I can figure it out really easily in my head, but let's make sure that we're showing the work with what we've memorized. I do know a kilometer is 1,000 meters. And so I can go to kilometer and say, well, that's 1,000 meters in a kilometer, in a kilometer, right? And so make sure that you remember small numbers with the big units, big numbers with the small units. Okay, make sure that you always keep those things tandem together or put together. Now my kilometers, one's on top and one's on bottom, they cancel out, that's 1. Now I want to go to millimeters. Do I remember how many millimeters there are in a meter? Yeah, I think I do. I memorized that, right? A milli is 1,000. And what goes on bottom? The thing goes on bottom that's going to cancel with the thing on top. So meters has to go on bottom, meters on top there. And now I can put millimeters right there. And I know that for every 1 meter, I've got 1,000 millimeters. Okay? So now I can come up with my answer because my meters are canceled off. My kilometers are canceled off. I went from kilometers to millimeters. Look, I've got millimeters. You might want to circle that just to help to remind yourself and take note of what's going on. 1,000 times 1,000 times 15.7, right? And then that's going to be your answer. Now, we haven't talked about scientific notation yet, but you can express that answer in scientific notation. And you can basically just say, all right, well, 1.57 times 10 to the, and here again, we'll go over scientific notation in a bit. We haven't done that yet, but we've got the 6 zeros there, okay? Plus we've got one more 0 that we're going to be moving that across. And so times 10 to the 7th millimeters. If I did that right in my head, if I didn't, poo on me. No, sorry, okay. You'll find this out about me, that I don't necessarily do stuff in my head as well as some of you guys do. You guys have better, sharper math minds than I do. So let me pretend like that's right, because I'm pretty sure it is, but I could be wrong. You can correct me if I'm wrong. And that's how we do our conversions, okay? So we do our conversions using those unit equality factors, or unit equation factors. Don't forget to do those, because that's the way we got to do them here in this class. All right. So, boom, conversion factor. That's what we just talked about, right? It's the ratio derived from the equality between two different units that can be used to convert from one unit to the other. So, again, anytime you talk about a conversion factor, you hear me say that, it's going to be a ratio, okay? How quarters and dollars are related can be expressed as a conversion factor. You can have quarters on top and dollars on bottom, or dollars on top and quarters on bottom. Either one works, right? And so there's 4 different ways here that we're showing you that are all equal to 1. They're a unit equality. We like to call them unit equalities because they're going to just, be equal to each other. And they are each equal to 1. 4 quarters per dollar, or let's flip it, $1 for 4 quarters. Okay, both equal to 1. I can do a fraction of a dollar. Okay, $0.25 for every 1 quarter, or a quarter is equal to $0.25, right? So it's the same thing. Those are all conversion factors. And we call this dimensional analysis. And we do these problems while we focus on the units. And this is the beauty of chemistry and physics, that if you focus on the units, that you can come up with the answers. And you don't have to do like complicated problems and complicated formulas a lot of times if you just focus in on the units. It's a lot of fun. All right, so you write down your given quantity. You figure out what conversion factors are going to relate the two to each other, going from the original unit to the final unit. And then you set up those conversion factors so that the original units are going to cancel and solve. All right, so that's what I just did for you guys. I showed you how to do that just a second ago. Now, here's another problem. Not a problem, but another way to think about this. This is kind of like a gift tag. You notice a little gift tag here. We have a to and a from. If you arrange your conversion factors like a gift tag, where you're saying the unit you're converting to goes on top, the unit you're converting from goes on bottom. So as you're creating those little unit conversion factors, I said always make sure the thing on bottom cancels out. But another way to think about it is like a gift tag, all right? The thing you're going to is on top. The thing you're going from is on bottom. That's another way to think about it. Some of you guys like different ways to think about things. Expressing a mass of 5.712 grams in milligrams and in kilograms. All right. So hit the pause button. See if you can do it. Pause it. Did it. Here we go. Now what we have is 5.712 grams. That's our given. Always start with what you're given. And then convert. I'm converting to what from what? Well, now if I can go straight to kilograms or milligrams because I've memorized it, then that makes it easy, right? So I'm going to what from what? I'm going from the grams where I was to the milligrams. Now I know how many milligrams are in a gram because I have done my memorizing, and I know that there's 1,000 milligrams in a gram. You see how much easier that is when you memorize milli is 1,000, right? It's 1 gram is equal to 1,000 of these littler guys, okay? So then our grams cancel. We've got milligrams, and so we're multiplying. That's going to move this over 3 zeros. So we're going to be at 5,712 milligrams. We do that same thing with this problem, 5.712 grams, and now we want to convert it to kilograms. We still are going from the grams, but now we're going to the kilograms. Don't forget, smaller number goes with bigger unit. Smaller number goes with bigger unit. Bigger number goes with smaller unit, okay? So the grams are still canceling, and now I've got to divide this out. And so now I've got to move my decimal place over 3 places in the other direction. So it's 0.005712 grams. Kilograms. Kilograms, okay? So, again, using unit conversion factors to solve these problems, that's the way we want you guys to do them, okay? All right, I'm going to erase that. And again, this is just kind of showing you what it looks like. And remember, we would box our final answer, and I didn't do that when I was showing that to you. That would be one extra step I should have showed you, is that we would take that and have a final answer that should be boxed. So don't forget to box those final answers, okay? So 5,712 milligrams, and if we did it the other way, 0.005712 kilograms. Cool? Cool. All right. Now, notice that here we are not showing the step problems. We're not giving you the full, set of step problems. I don't need you to do step format for unit conversion factors, okay? Just show me how the units cancel. If the units are canceling, boom, boom, and you're showing me them cancel, that's good. Get your units there, get them to cross off, show that little slash, and you're good. You don't have to show me step format for just doing conversion factors, okay? And some of those you're going to know in your head, right? From grams to kilograms, things like that. So you won't even have to show me that stuff. Okay, here we go. Again, place for you to practice. We'll probably do these in class, so I make sure you know how to do it in person live. At some point, we'll do at least things like this. But try it here on your own. Ready? Pause it. And we're back. Okay. And let's see if we've got the answers here. Boom. 851 milliliters and 0.00024 kilometers were the answers. Okay, so now we can do what we set out to do. All right, all of our objectives are now met. Now we can actually do this one right here where it says to list and convert between the SI prefixes. And of course, we were able to do those others before. So we are golden. We can be given 2 prefixes per unit. We can convert a quantity between them. And so we're good to go there as well. Awesome. Okay. So that's it for this lecture. Again, super useful stuff. When we're converting, from one thing to the next, whether we're doing unit conversions or whatever. Like I go to the gas station and sometimes I want to see what my mileage is and whether my car has got the same mileage on that trip as another trip, or, how things are going. I use this kind of stuff on a day-to-day basis for various different types of things. Again, like I said, maybe you're doing a cooking show from one country and you want to see what that converts to, using cups to milliliters, things like that. This kind of stuff is very useful, and I hope that you've got a good little review of it. I know this is kind of probably all review, but hopefully it kind of reviewed those concepts in your mind so you can master it the next time when you take your exam. Okay, have a great day.